Welcome everyone, I am Unchal Pal. Today we will solve a LeetCode problem step by step. The problem number is 2044, which is count number of maximum bitwise OR subsets. Let's see the problem statement. Given an integer array nums, find the maximum possible bitwise OR of a subset of nums and return the number of different non-empty subsets with the maximum bitwise OR. An array A is a subset of an array B if A can be obtained from B by deleting some elements of B, possibly zero elements. Two subsets are considered different if the indices of the element chosen are different. And the bitwise OR of an array is equal to the bitwise OR of all the elements present in that array, and the array is zero index. Let's see the example one. The example one is, let's say the nums are 3 and 1. So first we need to find the maximum bitwise OR. To find the maximum bitwise OR, we will perform bitwise OR to all the elements uh, present in nums given array. Okay. Then we will get the bitwise OR. So the bitwise OR or maximum bitwise OR of all the elements present in nums is 3. So we need to check how many different subsets are there which have the bitwise OR of 3. So you can see the 3 itself is a subset of that, and the 3 one is also a subset of the array. So the answer is 2. And the constraints are the length of the nums will be from 1 to 16, and each of the element will be up to 10 to the power 5. So as the length of the given array is very less, so we do not need to think about the time complexity. It could be like exponential. So we will use recursion to solve this problem. Let's see how the recursion will work. So each of the position of the nums, there are two possibilities. Either we will take the current element into the current subset we are making, or otherwise we will not include the current element in the current subset. So there are two possibilities. So we will call the recursive function for both of the possibilities, and then we will return the result of both the recursion function what they will give. Okay, that will be our solution. So let's first we need to calculate the maximum bitwise OR value. To do that, I already told you we will perform bitwise OR between all the elements present in nums. Let's say it is target. Initially it is 0 because bitwise OR of like any element like 0 or 1. If you bitwise OR, 0 is the element. If you perform bitwise OR with the another element, like let's say 1 or 0 anything, then the bitwise OR will be that element. So we need the default value as 0. Then for all the elements present in nums, we will calculate the bitwise OR. Let's say target is equal to, not is equal to, let's say directly we can write target is bitwise OR. This sign is bitwise OR equal to it. That's it. Now after the for loop, we will get the maximum bitwise OR value. Now we will call a recursion function. Let's say the recursion function is solved. First we need to pass the array, obviously. Then the size of the array, you can pass it, or you can also calculate it from dot size method also in that function, recursion function, but I prefer passing the value. Then the initial current initial index will be 0. Then our target value, of course, to know what is the maximum value, and the current uh, odd value, like bitwise odd value of all the elements of the current subset. So initially the current subset is has no element, so the bitwise OR will be 0. That's it. Now let's make the recursion function. Return type will be int, name is solve, and it will take the parameter first the nums, then it will take the size n, I will be the current index. I am taking the target as t and the current value. Okay. So first we need to check if the current index is already exceeded. the like our given array or not. To check that, we will check if I is equal to n or not, because as it is a zero index array, the maximum index could be n minus 1. So if it is reached n, that means we do not have any elements remaining. So then we need to check if our target is achieved or not. So if target is equal to current, then we know target is achieved for the current subset. Then we need to increase the value by 1, or in recursive function we need to return 1, because the current subset is 1 subset, so we need to return 1, and otherwise we need to return 0, because the current subset is not the actual not satisfying the conditions. Okay, next, I already told you there are two possibilities. One is taking the current element in our current subset, or we will not add the current element in our current subset. So to do that, let's say first no take. No take will be solve nums. N will be the same. I will be I plus 1, because now we will omit the current element. So I plus 1, target will be the same, and current will be also the same, because we are not including the current element. So current the next current value will be the same as the current value. Okay, now when we calculate for take, so solve nums will be the same, n will be the same, I plus 1, target will be the same, but the current will be the current value along with bitwise or with the current index value. Like for the next current value will be current bitwise or nums of I, because nums of I is the current element, and if we include that, then the bitwise, we need to perform the bitwise or operation along the previously current and the current element. Okay, now we need to return the sum of both the possibilities. So no take plus n. That's it. Let's see will it work or not. It is accepted. Let's submit it. So it is accepted. Let me discuss the time and space complexities of this algorithm. So this for loop is taking big of n time, where n is the length of nums, because we need to find the maximum bitwise or of all the elements. And this recursion function, as there are two possibilities, one is no take, one is take. So for each of the index, there are, like if you draw the recursion tree, it will grow exponentially, and as there are two recursion calls, so the overall time complexity of this recursion function will be 2 to the power n, where n is the length of nums. So in total, if we combine both of them, so overall time complexity will be big of 2 to the power n, and space complexity will be big of constant, for because we are not creating any list or array which is depending on the length of nums, but as we are creating the recursion function, we are calling recursion function, so the depth of the recursion function could go up to the length of the nums, which is n. So it could go up to the depth of n, because for zeroth element we are calling 1, then for one index we are calling 2, like that. So the depth of the recursion function could go up to the length of the given nums. So the overall space complexity will be big of n. So thanks for watching. If you want to check out the code, you will find it in the description box below. So that's it for today. See you in the next video.